Hello everyone and welcome to another episode of Math with Dr. War. We're continuing with our exam review and we're going to try to get in the next 10 problems. So our first problem we have to write in simplest form. So we have 2 square root 9 and I'm adding 3 square root 50 and I'm subtracting square root of 32. Now, when you have to simplify your radicals, your first step is to simplify each radical because we cannot add or subtract because every radical here is different. In order for you to add or subtract radicals, they must be the same. So I have 2, the square root of 9 is 3, so that's going to be 2 times 3. If a number is perfect and you take the square root, your answer is just a number. The square root sign is not present. Plus 3. Now we have to take the square root of 50, so I'm going to break that up into 2 factors. The best 2 factors for 50 is 25 times 2 because 25 is perfect, minus, we're going to take the square root of 32. And remember from class I said when you see 32, the best numbers to use are 16 times 2. Now 2 times 3 is 6, plus I have 3. If I take the square root of 25, that will give me 5. I cannot take the square root of 2, so that stays in the radical sign. Minus, the square root of 16 is 4. I can't take the square root of 2, so that stays in the radical sign. That leaves me with 6 plus 15, square root 2, minus 4 square root 2. Now on the final, please don't leave your answer like this. Always look to see if you can combine like terms, and your like terms are the 15 square root 2 and the minus 4 square root 2. Now we can combine those. Now when you combine, you're only combining the coefficients that are in front. So plus, so here it would be the 15 minus the 4, and you're going to keep the square root 2. So that will be 6 plus 15 minus 4 is 11 square root 2. And that's your answer. Okay, here we have to solve, and I have 36m squared equals to 25. Now when you see the 2 right here, that clues you in that you have a quadratic equation. And once you have a quadratic equation, remember your steps. You must set to 0. Then you factor. And then you solve. So I have 36m squared equals to 25. I'm going to set to 0, so I'm going to subtract 25 on both sides. This leaves me with 36m squared minus 25 equals to 0. Remember, when you only have 2 terms, there are only 2 types of factoring you can use, dots or GCF. But because I noticed that 36 is perfect, m squared is perfect, I have a subtraction and 25 is perfect, this will be the scenario we use dots, which is difference of 2 squares. So I'm just going to open my parentheses. 36 is 6 times 6. M squared is m times m. You see the minus, so which means your signs will have to be opposite. And 25 is 5 times 5. Your next step is to set each factor to 0 and solve. Now to solve this, I would subtract 5 on both sides. I get 6m equals negative 5. Solving for m, divide both sides by 6. So m equals negative 5 over 6. Now, if you know that you did this side correctly, your answer for the opposite side would be a positive 5 over 6. And this is your answer. Okay, we need to evaluate. Now I notice here I didn't see any variables. So this is the scenario. We use PEMDAS. Negative 5 minus 3 squared divided by negative 2. Take away 3 times 2 minus 6. Okay, let's work on this side. So negative 5. Okay, this is my operator, so I'm going to keep that. That's my subtraction sign. And if I square 3, that's 9 over negative 2. minus 3. Okay, 2 take away 6 is negative 4. If I go back over here, the negative 5 minus 9 is negative 14 divided by negative 2 minus 3 times negative 4. Negative 14 divided by negative 2 is a positive 7. Take away, and 3 times negative 4 is negative 12. And these two negatives come together and form a positive. So it's just 7 plus 12. Your answer is 19. 14, we have to simplify. Just look at your problem. Look at what's going on. When I look at this, I see parentheses. Now, whenever you see parentheses, your first step is to eliminate them. And once you eliminate them using the distribution law, then your next step should be to combine like terms. So I have 8x to the third minus 3x, which is multiplying 2x squared minus 3y minus 3y times 4x. Now remember, when you are distributing, the variable that's in front of the parentheses is what you distribute. So I'm going to keep my 8x to the third here. Negative 3x times 2x squared would give me negative 6x to the third. Negative, and notice I'm taking my sign, negative 3x times this negative 3y is going to give me a positive 9xy minus, now I have 3y times 4x, that would give me a 12, but for your variables, always write them in alphabetical order, so that would be 12xy. Now once you get rid of the parentheses, you're going to combine the like terms, which is this one and this. So this one's simple. 8x to the third minus 6x to the third is 2x to the third. And these are like terms as well. And you have 9xy minus 12xy. Your answer will be negative 3xy. Now this is your answer. Please do not try to subtract these two terms. They are not like terms. This is an x cubed, which is totally different from an xy. Okay, we have to factor. So it says factor completely, and that's the key word, completely. Now when I look at this factoring, I notice that it's multivariable. So I have more than one variables, and then they're raised to these really big exponents like 5 and 7. Whenever you see problems such as this, you're going to use GCF factor. So you have 24 x to the 5th, y to the 3rd, minus 16 x to the 7 y squared plus 8 x squared y squared. So what number would divide 24, 16, and 8 evenly? The answer is 8. Now let's look at our variables. Now x is common to all three terms, but which x would you take? Always take the one with the smallest exponent. So we're going to factor out x squared. Now let's look at the y. The y is common to all three terms, but again, we factor out the y with the smallest exponent, which would be y to the second. So when it comes to the variables and you're factoring, always take out the variable with the smallest exponent. Okay, always remember when you're factoring and it's GCF, you have to put the GCF outside your parentheses, because if you had to distribute, you want to get back the original. And to get what's inside, we're going to divide. So 24 divided by 8, that would give me 3. X to the 5th divided by x squared is going to be x to the 3rd. Y to the 3rd divided by y squared is y. So remember, when your bases match and you're dividing, keep your base and subtract your exponents. Minus 16 divided by 8 is 2. X to the 7 divided by x to the 2nd, that would give you x to the 5th. And then here, these y's cancel. Plus, okay, here the 8's cancels, the x squared cancels, and the y squared cancels. So this was a problem in class today. When everything cancels, you must write plus 1. Something will remain when everything is canceled. It does not become 0. It becomes a 1. And this is your answer. Okay, we need to factor completely. I have 4y squared minus 5y minus 6. So I see that this is a trinomial where my a is greater than 1. So remember, this is our AC method. So the 4 is going to multiply the 6. So it becomes y squared minus 5y minus 24. Now when your a is 1, this is easy to factor. So you know I like to put my x. Here's negative 24. Here is negative 5. Okay, y squared is y times y. Now this is a negative 24, which means 1 will be positive and 1 will be negative. Also, remember we took that 4 and multiplied the 6. We need to take it out, so you're going to divide everything by 4. I like to put all of this in because I find that students forget this last step, which is to divide by the 4. We took the 4 and multiplied the 6 to get 24. We put it into the 6. We have to now take it out by the method of division. And now we're going to find our factors. So I'm looking for two numbers that when I multiply, I get 24. But when I subtract, I get 5. So again, instead of guessing all over the place, let's look at our factors. Now 1 times 24. Now 1 times 24, if I subtract, I get 23. No. 2 times 12. If I subtract, I get 10. No. 3 times 8. 3 times 8 is 24, and if I subtract, I get 5. Now my 5 is supposed to be a negative. It means the 8 is going to be with the negative, and the 3 is going to be with the positive. Now when you get here, I suggest you check. Don't check the multiplication because it will always work. Check your sum. Now if I take positive 3 and negative 8 and I put them together, will I get negative 5? The answer is yes. Now over here, please don't leave your answer like this. Y plus 3 over 4. Okay, because I know I can't divide that evenly. This will be y minus, now I know 8 divided by 4 is 2. Please don't leave your answer like this. Always remember that this 4 right here, which is your denominator, is going to come and meet up with the y here. So this will be 4y plus 3. And then this will be y minus 2. And this is the answer I'm looking for. And again, to check your answer, I would suggest you do the FOIL method where you multiply. So this would be 4y times y is 4y squared. 4y times negative 2 would give me negative 8y. 3 times y is 3y. And 3 times negative 2 is negative 6. And then I get 4y squared. And when I combine the middle, I get negative 5y minus 6. So notice that when I did my check, I got back the original polynomial. Okay, we have to state the slope, the y-intercept, and sketch the graph. On your departmental final, I will give you graph paper. And the graph paper is for this question, where you have to indicate the slope, the y-intercept, and graph. I have 3x minus 2y equals to 4. From class, most of you liked rearranging the problem in terms of y, so I'm going to do that. So we're solving for y. So I'm going to write that here, solve for y. So I'm going to minus 3x on both sides. Negative 2y equals negative 3x plus 4. Divide both sides by negative 2. That goes. Notice that when I divided each term because we want a value for the slope and the y-intercept. So I have y equals, again, please don't leave your answer like this. 2 negatives gives a positive. So this is actually 3 over 2x. And then a positive divided by a negative is a negative, and 4 divided by 2 is 2. Then after you've gotten this, please, they said state. Don't leave this. This is an equation. So you can say your slope equals to 3 over 2. Your y-intercept is a point which is 0, negative 2. And then you have to graph. So I'm going to draw a line here. My line will be crooked. I am telling you from the start. Okay. So there's my line. Again, on the departmental final, please indicate your axes. Now, when you're graphing, the first step you're going to do is plot your point, which is 0, -2. So this is my origin, 0, 1, 2. So here, this is my y-intercept. And now I'm going to use my slope. And remember, your slope is rise over run. So I'm going to rise 3 units, 1, 2, 3. And then I'm going to run 2 units because it's positive. I'm running to the right, 1, 2. So this is my second point. And then I'm just going to connect them. Again, my line is going to be crooked. And you're finished. So notice when you have to graph the line, you're going to plot your y-intercept. You're going to use your slope. The rise is a +3, so we went up 3 units, 1, 2, 3. And then we ran 2 units to the right, and that gave us our second point, and we just connected them, and that's it. On the test, I will be checking your rise and your run, because I find students just put in the y-intercept and then just draw any old line, like they just draw a line and hope for the best. Question 18, we have to simplify completely. Again, that word simplify. So you're looking at your problem and you're like, oh, I see the fraction bar, so I should be able to divide. But I didn't teach you how to divide a polynomial by a binomial. Because it says simplify, I did teach you a couple of things. To solve this, you're going to factor the numerator and factor the denominator, and then you're going to look to see if anything can be canceled out. So I have 5x squared plus 15x divided by x squared minus 9. Now, the numerator has 2 terms, and remember, if you have 2 terms, you're either using GCF or dots. Now 5 isn't perfect, so this is clearly a GCF. So if I go over here at the side, 5x squared plus 15x, I can factor out the 5x. So if I factor out 5x, so there's my 5x, what will be left inside would be x plus 3. Because this cancels, x squared divided by x is x, 15 divided by 5 is 3, and that cancel. So this was a GCF, and I left with 5x and x plus 3. Now at the bottom again, it only has 2 terms, but I know x squared is perfect and 9 is perfect. So the bottom, we can use dots. So I have x plus 3, and this will be x minus 3. Because x squared is x times x, the negative means plus and a minus, and 9 is 3 times 3. And then you look to see what you can cancel. So this will cancel this. And what do you have left? You have 5x in the numerator position, and the denominator position you have x minus 3. And that's your answer. Question 19, we have to simplify completely. Again, that word simplify. So take a look at your problem. It looks like you're multiplying. So you're like, oh, I have to multiply this. But notice these numbers are really huge. Well, not really huge, but to me they're huge. So remember from class, I split this up into 2 problems. So we're going to look at the coefficients. So I have 22 over 27 that I'm multiplying by. Now, in class, I said, get rid of the sign. Like, look to see what would be the sign for your answer. So this is positive, this is negative. A positive times a negative is a negative. So my answer will be negative. I know my answer is going to be negative. So I want to put this as 18 over 55. Now, when you're multiplying fractions, students like to multiply straight across. You can do that if you want to. But if you do, be warned, your numbers will be really big and you're going to have to simplify. Like, what is the factors of 22? To get 22, that's 2 times 11 times, to get 18 is 2 times 9. Okay, 27 is 3 times 9, And 55 is 5 times 11. So notice what I did. I brought 22, 27, 18, and 55 into their factors. And I looked for like factors. So when I got the 18, I chose 2 times 9 rather than 6 times 3 because I saw the 27. Okay, let's start canceling. This 11 cancels this. This 9 cancels this. So what are you left with? 2 times 2 is 4 over 3 times 5 is 15. And that is, and always check your fraction. This is as small as it can get. So my fraction is 4 over 15, and it will be negative. Now let's work on our variables. So I have x squared, y to the 8th, multiplying with xy, and then down here I have x to the 6th, which is multiplying by x to the 4, y to the 3rd. Alright, let's look at the numerator. X squared times x is x to the 3rd. And then the y, 8 plus 1 is 9. At the bottom, x6 times x to the 4th. You keep your base and you're going to add 6 plus 4 is 10. And then you just have the y to the 3rd. Now we have to divide. Now here I know I'm dividing, but where is the most of your exponents? At the bottom. So I'm going to subtract as normal. 10 minus 3 is 7, but my answer is going to be in the up here. I notice the most of my exponents, well, the greatest exponent is the 9, and that's in the numerator. So my answer for y will be in the numerator, and 9 take away 3 is 6. So all that yucky stuff came to y6 over x7, and all I'm going to do is write it here, y6, x7, and this is my answer. Wasn't too difficult. Okay, we have to solve algebraically. So here we have two equations. So this is your systems of linear equations. So I have 3x plus 2y equals to 7 and 5x plus 6y equals to 1. So I notice I can't get rid of any variable. And in order to solve this, we have to make a variable the same. Most students usually go for y, so I'm going to do that. Alright, first thing I notice is that the signs are the same. In order for me to eliminate the y's, these must be opposite signs. So I'm going to put a negative here. And then this is 2. Can I make it a 6? Yes, I can. By multiplying by 3. So I'm going to multiply. That would give me negative 9x minus 6y equals negative 21. Please be careful. If you need to, please draw arrows. It helps. And then my second equation stays 5x plus 6y equals to 1. Now I can eliminate the y's by adding. Now when I add, I'm going to get negative 4x equals negative 20. And solving, I'm going to divide both sides by negative 4. So x has a value of positive 5. Now remember, they wanted you to solve these two equations. And you see there are two variables. One is x and one is y. So we found x. So to find y, I'm going to go back to the original equation, which is 3x plus 2y equals to 7. And I'm going to substitute x equals to 5. So wherever I see x, I'm going to replace it by 5. Once I do that, notice I only have one variable now, y. So this will be 15 plus 2y equals to 7. Solving for y, I would subtract 15 on both sides. So I have 2y equals, the signs are different. So we keep the sign the larger, we're going to subtract, that's going to give us 8. And solving for y, finally divide both sides by 2. So y has a value of negative 4. So x is 5 and y is negative 4. Again, you can go and check your answer. Okay, I'm going to use the bottom one. 5x plus 6y should give me 1. Okay, 5, x is 5 plus 6 and y is negative 4. 25 plus negative 24. When the signs are different, you subtract, so 1 equals to 1. So it worked. So these are my answers. Over here, I need to solve. This looks like an equation, but it's a fractional linear equation. Once you have a fractional linear equation, your first step is to find your LCD. And we did this today. Now to find your LCD, today in class, everyone was going after the smaller number. Start with your larger number, 12. Okay, can 2 divide 12 evenly? Yes. Can 4 divide 12 evenly? Yes. So your LCD is 12. Okay, to make this 12, I would have to times by 6. So this would be 6x. To make this 412, I would have to times by 3. So 3 times 3 is 9. And to make this remain 12, I would have to times by 1. So this is 5x. Once your denominators are all the same, you cross them out, and we're just going to work with your numerator, which is 6x plus 9 equals to 5x. Now you're solving for x. So I have an x on the left and an x on the right. Now I won't get rid of this x. I find that on tests. I have no idea why students get rid of this. This is not connected to anyone. Always go after who is connected to someone. So I would get rid of the 6x. So that would be minus 6x on both sides. So I have 9 equals, and then if I subtract that, I'm going to get negative 1x. But remember, your variable must always be positive. So you're going to divide both sides by negative 1. So x has a value of negative 9. And you're finished. I hope this has been helpful. Good luck in your examination.